Hello. Okay. So after uh, we have discussion about what? We have discussion about time constant and how we define the time constant. By looking at this waveform, we can say the time constant is time required by this response to attain 1 by 1 by e of the maximum value. That value is 1 by e of the maximum value. So one, you can have this kind of waveform. What is another waveform you can have for the time constant? So you can say for time constant, the calculation of time constant, the another kind of waveform we are having. Time constant, and we are taking case number 2. And what is case number 2? Let's say you are having a charging waveform. Some component is charging. Maybe it is inductor or capacitor, but some component is charging for a charging waveform. Charging. And only which type of charging is available? You can say in our component, we are having this kind of charging. So we are calling this value as x of t. We are calling this value as t. And let's say this is the maximum capacity till which a component is charging. And this is the kind of waveform. This is what? This is the charging waveform of some component. This point is x equal to infinity. And what kind of waveform this is? We can say that this waveform is known as xt equal to some k times of 1 minus e to the power minus of at, or a into t. Suppose you are having this kind of waveform, then in this condition how you will define that how fast or how slow charging process is? How fast or how slow the charging process is? Suppose you want to represent that thing. So the time required to reach, in this case means case number 2, the same variable is time constant, and we are defining time constant when some component is charging. So time constant for this waveform, time constant time required time required to reach k times of 1 minus e to the power minus 1 of final value is known as time constant. So what we are saying, suppose what is the final value of this? The final value is k, or any number. This can be any number. So what we are saying, the time when this value is reached to this point, when this value is k times of 1 minus e to the power 1, this value is known as time constant. And can I say what is the best idea to calculate the time constant? Make this two value equal. So k times of 1 minus e to the power minus at is equivalent to k times of 1 minus e to the power minus 1. This is possible when t is equivalent to tau, and tau is what? Time constant. So can I say from here e to the power minus of at is e to the power minus 1, and tau equal to what? 1 by a. So here also 1 by a is known as time constant of this charging waveform. So it is very simple. If something is written as e to the power minus of 2x, so 1 by 2 is the time constant, and time constant represents how fast or how slow the charging and discharging process is. Always remember, time constant is not defined for oscillatory waveform. So you are having this kind of expression. This expression is known as charging expression, because when you take, because this expression is only valid for t greater than or equal to 0. So if you take t equal to 0, the value will be 0, and when you take t equal to infinite, that value will be what? K. So when you reach 1 minus e to the power minus 1 of final value, or you can say e to the power minus 1 is minus 1, 63% of the final value. So one more definition which is available, but this definition will be helpful to calculate the value of the expression. Time constant what I can say, time required by response to reach 63.2% of the final value is known as time constant. Correct? This is the value of time constant. You have to remember a few more things. Suppose you are having this kind of waveform. Suppose you are having this oscillatory waveforms. This is type 3. Suppose we are having some oscillatory waveform. This process will not settle down, so time constant is not defined for this kind of waveform. Oscillatory waveform, there is no such thing like a time constant. So uh, I hope. And what is the time constant of this type 4? You can say, suppose in case of impulse the time constant is 0. If time constant is 0, and suppose we are having one steady process, so you can say a process is steady, time constant is equivalent to infinite. So you can say this process is impulsive charging or discharging. When you are having this kind of waveform, this is known as impulsive charging or discharging. Impulsive response. And this is constant process, so the process has reached up to the steady state. So time constant is only defined for these two waveforms, when you are having this kind of waveform or when you are having this kind of waveform. And luckily in our circuit analysis, in our first order analysis, we are only having these two kinds of waveform. Correct? So let's start with our first example we did. Let's go to that example. So suppose I have this kind of waveform. I0 it equal to what? It is equivalent to V by R1 e to the power R1 plus R2 divided by L into T. So what is time constant here? The time constant here is when R1 plus R2 divided by L into time constant. This value is what? 1. Because it is discharging waveform, and in discharging waveform, uh, the time constant is written by what? L divided by R1 plus R2. So what is time constant here? The time constant here is L divided by R1 plus R2. So what is general formation of the waveform? The general formation of the waveform is this. You can define the time constant by L divided by R1 plus R2. This is the time constant. I hope this is clear. And this is our first circuit. In this circuit, we have analyzed the voltage, current, everything we have analyzed for the circuit. Now why you are having the voltage, initial voltage is negative? Because initial voltage comes across inductor comes from this law. The current voltage drop across this plus voltage drop across this will gives you the initial voltage. So you have to take care of this thing. Let's analyze our next circuit. And in first few circuits we will analyze the whole circuit. We'll don't go to any of the shortcuts for the circuit. So let's say this is our second example. In this example, let's talk about the circuit. And in maximum question, they talk about time constant. So we'll define in circuit in the whole response in terms of time constant, and we'll try to write the direct solution also. But first, try to get the understanding what question is trying to say. This is question number second. What this question is saying? This question is saying that we have to find the V2 for t greater than 0, and this is very conceptual circuit. V2 t for t greater than or equal to 0. We have to analyze the voltage across 2 Henry inductor for t greater than or 0. This is our second problem, and we want to analyze this problem across every component. Our first few analysis is for every component. Now what I am saying, what is initial position of the switch? Because as you know, the switch, you can analyze your circuit for the two position. The first position, when the circuit is available for t equal to minus infinite to t equal to 0 minus. And this point is very important because I am not interested in this point for t greater than 0, but you have to copy the current because we are analyzing the case of inductor. In case of inductor, we have to copy the current from circuit 2 to circuit from previous condition to next condition. So these 2 points are very important for us. We are not at all interested because what question is asking to analyze the circuit for t greater than 0. Then why I am interested in t less than 0? I am interested in t less than 0 only to analyze the energy storing element. So let's analyze the circuit for t less than 0, or even if I am not interested at t is equal to minus infinity. I am interested only at the point when t equal to 0 minus. So can I say at t equal to 0 minus means just before we are changing the position of the switch. How will switch looks like? This is 1 volt source, and this is resistance. Resistance is unaffected by the initial value and steady state value. But what I can say that here I can connect one inductor and I will replace this inductor by short circuit. That's the most important point. Why I am replacing it by short circuit? I am replacing it by short circuit because this is one inductor, and how inductor behaves in the steady state, because this circuit, this switch has attained the steady state position at t equal to minus infinite, because we consider that every switch is having one stable position. So switch is at position A from which time duration? The switch is at position A for time duration of minus infinite to 0 minus. So can I say the position A has achieved the steady state condition at t0 minus, and in steady state how this behave? Inductor behaves as a short circuit. So can I say I0 minus equal to what? I0 minus is applied potential divided by resistance. So applied potential difference is 1 volt, resistance is 1 ohm. So you can say I0 minus is equivalent to 1 ampere. And you are charging in which direction? You are charging in downward direction. So what is your takeaway from the circuit which is available for t less than 0, or the circuit which is available for t0 minus? Your takeaway is that 1 Henry inductor is charged by how many amperes? It is charged by 0 amperes, 1 ampere. So can I say I0 minus is equivalent to 1 ampere. And what you will say? You will say that, sir, this is energy storing element, so I can copy this condition from I0 minus to I0 plus. This is the only situation we need to analyze. This is only thing we need from the circuit available at T0 minus. But what is new about this circuit? In this circuit we are having two energy storing elements. In this circuit we are having two energy storing elements, and these two energy storing elements are having different nature. 1 Henry inductor we are charging from the 1 volt, while 2 Henry inductor is not charged at all. It is not connected to any supply. So, but we are interested in what? We are interested in only circuit at t greater than 0. So let's draw the circuit for t greater than 0. Can I say, if we draw the circuit for t greater than 0 or equal to 0, because our differential equation is only valid in this duration, our circuit will looks like this. Our circuit will looks like this. This is 1 Henry inductor. Then we are having what? One resistance, 1 by 2 ohm, and then we are having 2 Henry inductor. Correct? What else we are having? They are telling us to calculate the voltage across inductor. So all three components are connected in the series. If all three components connected in the series, the voltage across each component is the same. Now these two elements are different. This is 1 Henry inductor which is having finite initial condition, and another one is 2 Henry inductor which do not have any initial condition. So let's analyze for t greater than or equal to 0. Can I say, if I assume this point as my reference, 0 volt, then this potential will be what? This potential will be V2T. If this potential is V2T, we can apply one KCL. What we can apply? We can apply one KCL here, Kirchhoff's current law. So what is current in this inductor, 1 Henry inductor? So you know that the current in the inductor is 1 by L integration of V2 dt. So let me write KCL. This is 1 by L. L is 1 Henry, integration of V2 T into dt. This much of current you can expect from inductor number 1. What is current in the second resistor? The second resistor is potential difference divided by resistance. So V2T divided by 1 by 2 is the current across the second component. And what is current across the third component? You can say the current across third component is 1 by 2, 1 by L. So L is 2, integration of V2 T into dt. This is our whole circuit. Because this and the summation of this voltage is equivalent to what? The summation of this voltage is equivalent to 0. As we know, if summation of the voltage is 0, can I say our we can differentiate it. So 1 plus half is 3 by 2. Our equation will become 3 by 2 integration of V2T dt plus 2 times of V2T equal to 0. So one integral operator is available here, and we want to form a differential equation. So how to solve this differential equation? Just differentiate both sides. Take d by dt of both sides. If I take d by dt both sides, we are not using any kind of shortcut. We are just solving the differential equation, forming the differential equation. We are interested in the exact analysis, how it looks like. So you can say this is 3 by 2 V2T. If I differentiate it, and this will be 2 dV2T divided by dt. Correct? This equation is a homogeneous differential equation. You can solve it by variable separation, but the coefficient of this factor, we want this coefficient to be 1. So if we want this coefficient to be 1, I can say I can take 2 common. So this is dv2t divided by dt plus we are having 3 by 4 v2t, and this value is equivalent to what? This value is 0. Now we know the solution of this differential equation. What is solution of this differential equation? The solution of the differential equation is v2t equal to what? v2t equal to some constant times of e to the power minus of 3 by 4 into t. Yes or no? Because we know the solution, we have derived this solution. And what is this k? So can I say this differential equation is valid only for t greater than or equal to 0. So if we put v2 0 plus, I am replacing t by 0 plus, this value is k. So you can say v2t is nothing but v2 0 plus into e to the power minus of 3 by 4 t. This is very interesting expression. But there is a problem. What is the problem? That we have initial condition for the inductor. We have initial condition for what? Inductor. And here we want answer for what? Voltage. But for voltage you cannot copy the voltage from position 1 to position 2. Because what was the position at voltage at position 1? Now you have to observe this. If I am writing what is VL0 minus, the VL0 minus is equivalent to 0. Why? Because inductor is short circuited. But as we know that for inductor you can copy the condition of current, not you can copy the condition of voltage, because voltage can abruptly change from 0 plus to 0 minus. So you cannot write VL0 minus equal to VL0 plus. This is not valid expression. You can only copy the current. So with the help of this current we will try to achieve what is V0 plus. So to calculate the initial condition, because now our answer is ready, we are only interested in what? We are only interested in this V20 plus. So can I say, let's draw our circuit at, and why we are doing this? We are doing this to calculate the initial condition only. Let me go to the next. Okay, let me draw the circuit. At which moment we are drawing the circuit? Only at t equal to 0 plus, because we are interested in the voltage at t equal to 0 plus. So can I say at t equal to 0 plus, how your inductor is behaving? So you can say the inductor number 1, the 1 Henry inductor is behaving as a current source of 1 ampere. So can I say this inductor is acting as a current source of how many amperes? 1 ampere. Always remember, you cannot copy the voltage from T0 minus to T0 plus across one inductor. Very good. Now, can you tell me what is the resistance? So resistance do not vary with the time. I am calling it 1 by 2 ohm. It do vary with time, but in not our questions. And what is condition of your inductor? Can you tell me what is condition of our inductor at T0 minus? So you can copy the current, that's why we are copying the current. But you can say the inductor number 2, the 2 Henry inductor was not connected to the supply. What is our observation? 2 Henry inductor not connected to if 2 Henry inductor is not connected to the supply, can I say the current stored by this 2 inductor is 0 ampere? If the current is 0 ampere, can I say 0 ampere can be written as open circuit? This is special in this question, that we are only charging out of 2 inductors, we are only charging one inductor. Only one inductor is having initial condition, another inductor do not have any initial condition. So you can, if you are interested in the initial condition of the voltage, you have to calculate this voltage. You cannot copy from previous case to this case. So can I say this voltage can be written as V20 plus. And what is the V20 plus? We can say the current will enter from this polarity. So this will be plus, this will be minus. So V20 plus will equal to what? V20 plus equal to minus of 1 by 2 volt. And now you are having your complete solution. So remember, what is the very important learning from this question? Initial condition is known for circuit number t less than 0, and this initial condition is given for current. But if we are interested in the initial condition for the voltage, then you have to draw the circuit at t0 plus and have to calculate this. So what is our final solution? The final solution V2t is given by minus of 1 by 2 e to the power minus of 3 by 4 t. And always remember, this value is valid for t greater than or equal to 0. This solution is not valid for t less than or equal to 0. If you know the value of voltage, you can find the value of current also across. If you ask me what is the current in this branch, so current in this branch is V2t divided by 1 by 2. So current in this branch you can calculate. You can calculate every current and voltage of the circuit. But what is important? Only one inductor is charging. This inductor is having initial condition. And this inductor do not have any initial condition. And second thing, initial condition is given for current, but we are interested in voltage. That's why we have to draw this circuit again and calculate the initial condition for voltage. You cannot copy this. What I am saying, what was the initial condition of this 1 Henry inductor? So we were saying that its a potential is 0, and 0 to it is jumping at minus 1 by 2. So there is an abrupt change in the voltage across inductor, and that is possible. Inductor will resist the abrupt change in the current. It will not resist the abrupt change in the voltage. So keep this thing in mind. Correct? What is time constant? So here you can say the time constant for the circuit is given by 4 by 3. The value of time that requires to make this exponent equal to minus 1 is known as time constant. So I hope you have understood this whole question for the voltage. They are asking the V2t. Let's have one more question. In this question, the source is also given as e to the power minus of t, means the nature of source is also decaying, and they are asking the voltage across capacitor. So what is the question? Find the voltage across capacitor. Find VCT, V2t for t greater than or equal to 0. Find V2t for t greater than or equal to 0. How we can approach this question? Again, our agenda is the same. What agenda we are having? We will analyze the circuit for t less than 0. We will analyze the circuit for t less than 0, and then we will go for t greater than 0. Or let's take one more question here. Okay, let's take this case. We'll try to first take this case, and then we'll go to the next question. Let's say this is our example number 3 on the RL circuit, because here we are analyzing which circuits? RL circuit. So we have our both example is from RL circuit. So we are taking third question from RL circuit, then we will come to the RC circuit. Okay, so what they're asking what is the value of current IT for t greater than or equal to 0. This is our question. So again, one switch is working here. If one switch is working here, what I can say, we have to analyze this current, because this is inductor and we are writing the current across inductor, so both the situation will be same. So can I say in this question also we are having one switch, we are having one switch. Again, I am calling this point as t equal to infinite, but no, we are not interested in this duration. What is happening at t equal to minus infinite to t equal to 0 minus? Because I am interested in the writing the response of the circuit for t greater than 0, and to write that response I am only interested at this point. This is a steady state point. So can I say for t equal to 0 minus, in this steady state condition, what condition is this? Steady state condition. In this steady state condition, the switch was, initially switch was closed. So can I say my circuit looks like this in this condition? A 10 volt, we are having 10 volt. Then this whole segment is connected to the short circuit. Which segment is connected to the short circuit? You can say this whole circuit is connected to the short circuit. So we will across a short circuit potential is 0, so I will not write this. Then what we are having, 20 ohm resistance, and I can replace inductor by a short circuit. Why I am writing inductor by a short circuit? Because in steady state how inductor will behave, in a steady state inductor will behave as a short circuit. So we are taking inductor as a short circuit. This is our short circuit inductor. And can I say this is the current in a steady state of the position number 1. So I am calling this current as I0 minus. And what is this current? From KC KVL we can say I0 minus is 10 divided by 20, and 10 divided by 20 is what? Half ampere. Now we are having only one energy storing element, so you can copy I0 minus, and that element is inductor. So you can say 0 minus current, which is half ampere. You can copy this current here, which is t equal to 0 plus. You can copy this current here. And how this current will help you? This current will help you to find the initial condition, that constant which is very important. We can call this current as I0 minus to I0 plus. Only what is the significance of the circuit for t less than 0? Only this is the significance, because we are interested in the coefficient of differential equation, and coefficient of the differential equation can be calculated only if we can copy this. Correct? Now we are interested in now we are interested in Now we are interested in analyzing the circuit for t greater than 0. So can I say for t greater than 0, the circuit will looks like this. That at t greater than 0, the switch is open. If switch is open, 20 volt and 10 volt will appear in series. If 20 volt and 10 volt will appear in series, you can say if 20 volt and 10 volt will appear in series, this potential will be what? This potential will be 30 volt. Then 20 and 30 ohm will appear in series. So you can say this value is what? 50 ohm. And you can, because all will participate now. Now you can say we are having one inductor, so I am taking this inductor into the action. Now what is one question? I am saying that I don't need now a circuit for t equal to 0 plus. Why? Because I am writing the current equation and initial condition is also given for the current, so I don't need to write it. Now let's say this current is IT. If this current is IT, can I say if I apply KVL here, I can say 30 equal to what? 30 is equivalent to, I can say 30 is equivalent to 50 times of IT plus L di by dt is the voltage. So L is 1 by 2 Henry. I will tell you the shortcut to calculate this also, but first develop the understanding how this thing appears. So this value will be 60 because we want coefficient of di by dt equal to 1. So this will be 60. This will be 100. This is IT and this value is what? dit divided by dt. Correct? This is what? This is the order one linear differential equation with the constant coefficient. So you can say what is the integrating factor here? The integrating factor here is e to the power p dt. So e to the power 100t is the integrating factor. So you can say what is solution? The solution for dependent variable it into e to the power 100 of t equal to how much? Equal to integration of e to the power 100t into 60 into dt. When I solve this integral, it is 60 divided by 100. And when you bring this e to the power minus 100t here, plus 100t minus 100t cancel, plus one integrating constant k. So it is k into e to the power minus of 100t. Or you can write k here. Fine. Or you can say what is the value of current? The value of current is 0.6 plus k times of e to the power minus of 100t. This is the value of current you are having inside the loop. Now we are interested in the value of k. And as you know, the solution of this differential equation is valid only for t greater than or equal to 0. If this solution is valid for t greater than or equal to 0, I have to write equation it equal to 0.6 plus k into e to the power minus of 100t. So what is value of I0 plus? So you can say I0 plus equal to 0.6 plus k. And what is value of I0 plus? We already know the value of I0 plus, it is 1 by 2 ampere. And also this is going in the downward direction. So you can say this value is 0.5 equal to 0.6 plus k. So k equal to what? K equal to minus 0.1. Now you can write the complete solution. So what we have to take care? We have to take care about this, that you have to write the solution by adding CF and PI. You cannot write solution. You cannot write solution only by looking at CF. So CF and PI both. So if I say I am interested in the complete solution, the complete solution is given I by IT and the value of IT is equivalent to 0.6 plus 0.6, and what is value of k? The value of k is minus 1, and this is very important point, minus 0.1 into e to the power minus of 100t into e to the power how much? Minus of 100t. So we know the everything for this circuit. If I want to draw the waveform of current, the waveform of current will looks like this. The waveform of current will looks like this. What I can say, if this is my IT and this represents t, then what I can say, what is the initial value? So when I put t equal to 0, the initial value is 0.5. As we already know it, this value is 0.5. 0.5 what? 0.5 ampere, correct? And what is the final value of this? At final value, this if I am interested in I of infinity, I can say I at t equal to infinity will be what? If you put t equal to infinity, this value will be what? 0.6 ampere. So if I write 0.6 ampere here, your inductor is charging from what? 0.5 to 0.6. And this can be the waveform. Or let me use this pen. And this value is what? This value is 0.6. This is the idea of this is the whole idea of the current across inductor. Now we can write the potential across inductor also. That is also not a difficult job because we know what is the potential across inductor. We know that the potential across inductor is we can calculate the initial potential also. We can write the, because you know that it is L di by dt, L dit divided by dt is what? The potential across inductor. You know the voltage waveform, so you know the current waveform. If current waveform is known, then just multiply it by what? If you know the current waveform, just differentiate the current waveform and multiply it by half. So you can say VLT, the voltage across inductor, is given by 1 by 2 times of how much? 1 by 2 times of 1 by 2 is what? The value of inductor and derivative of this. So when you take derivative of this is minus 10. If you bring minus 100 here, minus 0.1 into minus 100 will be what? 10 volt. So 10 times of e to the power minus of 100t. And can I say this value will be what? 5 into e to the power minus of 100t. And this expression is only valid for t greater than 0. So if I draw the voltage waveform, the voltage waveform will looks like this. If I am interested in the voltage, what is initial voltage? At t equal to 0, it's a 5 volt, and as time increases, it will go to 0. So this is the overall analysis of voltage and current across inductor. And you can write the voltage and current across any component. If you are interested in the voltage across this component, just multiply your current by 20. This is the voltage across 20 ohm resistance. Just multiply it by 30. You can calculate the voltage across 30. If you are interested in the current across this, the current across this is also known. If you are interested in the energy or power, you can talk about energy also. So this is 30 multiplied by this waveform will gives you energy or power. But slowly we will reach up to every point of analysis. But right now, what was our concentration? Our concentration was on how to analyze one RL circuit without any direct shortcut. We will write shortcut also. We'll try to write everything, but first our focus is on the conceptual understanding. I hope you have understood this analysis well. In next class we will try to analyze one RC circuit with the help of this differential equations only. Then we will write the shortcut, then how shortcut will help you to write answer fast. Thank you very much.